Okay, this is GCSE Further Mechanics. We're doing uvast, that's constant acceleration, and velocity time graphs. So Sarah leaves home 2 minutes before Cody and walks at a constant velocity of 1.8 meters per second. Cody cycles after, remember that's 2 minutes later, accelerated from rest at 0.8 meters per second squared until he reaches a velocity of 12. He then maintains this velocity until he meets Sarah. After that, after he meets Sarah, he then decelerates uniformly to rest in 4 seconds. Sarah continues to walk with a constant velocity of 1.8. Part 1, draw velocity time graph to show these journeys. We've a wee bit to work out here, so let's see how So Sarah has a constant speed the whole time of 1.8, so I'm going to keep the 1.8 down here and keep it nice and low, so that's her the whole time. Hopefully you can see that of the line, will make it a bit thicker. So that's her. We'll do one of those wee squiggly things so we can start then after that. So then here we'll go at 120. So what's 120? That's our 2 minutes later. Remember we're in seconds, and this is Cody starting off here. So he accelerates until he gets up to his speed. It's just going to be up here, and I think then that's the 12. This is obviously velocity time graph in meters per second, and then he goes at a constant speed after that of 12 for a while until they reach each other. Let's call when they reach each other t. So if I do my t here, and then whenever they meet each other, he then slows down to 0. So we'll go with that, and that then will be t plus 4. So this is time, that's in seconds. This bit here is Sarah, and this bit here then is Cody. So what do we know here? We know this is 12. We know the acceleration is 0.8, so that means we can find the time there. So let's do that. So if we know Cody, the acceleration is 0.8. Therefore the gradient, remember acceleration equals gradient in a velocity time graph, is 0.8, which is 8 over 10. Or if you want, U is 0, V is 12, A is 0.8. If you wish you can use uvast, V equals U plus AT. 12 equals 0 plus 0.8 t. T is 12 over 0.8, and so that means the time it takes him to accelerate then is 15 seconds. So that means that if that's 120, it means down here then is going to be 135, which is useful then. Yeah, whenever we're trying to work this out. Okay, how long has Sarah been walking when Cody catches up with her? So effectively we're trying to work out our value for t. So let's take that information down. So B, I'll just move up, we can move back whenever we need the velocity time graph. Cody catches up. So they've travelled the same distance. We've let that time then be t. Sarah's distance. It's the area underneath this graph up to here. So that distance is t. This distance here is 1.8. So it's 1.8 t. Cody's distance is going to be the area of this. Oh, for goodness sake, Cody's distance is going to be, sorry, Sarah's distance there, that distance is t, and that distance is 1.8, so it's 1.8 t. And then Cody's distance is going to be the area of this big triangle and the area of this rectangle. So I'm going to call this S1 and S2. So Cody, S equals S1 plus S2. S1 is a half times 15 times 12. S2 is t minus 135. Do you see where I'm getting that from? That's 135, that's t plus then 135, so that distance here is t minus 135 multiplied then by 12. So that equals 12t minus 1620. And this here is obviously 90 meters, so his distance is 90 plus 12t minus 1620, which is 12t minus 1530. Cody's distance is 12t minus 1530. Sarah's distance is 1.8t, so we let them equal each other. Therefore 1.8t equals 12t minus 1530. Tidying this up, I'm going to take this, we'll do a bit of rearranging, hopefully you're having enough. Let's go 1530 equals 10.2t, so t is 1530 divided by 10.2, and that gives us then 150 seconds. The other way we have of doing this, if we need to, is to use uvas and t, and we can solve them all like that. So that's part B. Next then on to part C. Remember, we're worried about space, so hopefully we'll be able to fit everything in. Part C, find the distance from home Sarah has walked when Cody catches up with her. So we know it's 150 seconds, so it's just a case of working out then the distance. So the easiest way is to do it with Sarah's one. So Sarah's 1.8t, Sarah is 1.8 multiplied by 150, and that then is going to be 270 meters. Part D, find Cody's deceleration. So this is kind of part 3 then of this bit, and so we need to then try and work this bit out. So we know that's 12, I suppose. We know that time is going to be 4, so we can just work it out then from there. So we could either use our rise over run, and I know that's 12, and I know that's 4. Again, perfect video here, you can't see it. And so our deceleration is 12 over 4, and it's equal to 3 meters per second squared. Now be careful here, I just sort of have my wits about me, because that's it going downhill. So for an acceleration, of course, that would be a negative gradient, but because it's deceleration, we're happy that it's going to be that. And the other way you could use it, and we'll just do this one at a time, or we could use U, V, A, S and T and find their acceleration. What do we know about that final little bit of the journey? We know U is 12, we know V is 0, acceleration we're trying to work out takes 4 seconds. So we could use V equals U plus AT, 0 is 12 plus 4A, 4A is minus 12, A is minus 3, so our A is minus 3, therefore our deceleration is 3. Finally on to part E. So part E says find the distance between Cody and Sarah when Cody stops. So let's take a look. Sarah will have travelled for 4 seconds at 1.8, so that's going to be nice and straightforward. 1.8 times 4, and then how far has Cody started? His distance then is the area of this triangle. So we'll work it out from that. Or again, if you wanted, you could use you could use uvast to work those out. So let's write those down. Sarah distance (1.8 times by 4). So she has travelled 7.2 meters. Cody is going to be the area of the triangle, so it's going to be a half BH, so it's a half of 4 times 12, and that gives me then 24 meters. As I said, you can use uvast for this. U, V, A, S and T will give you the same thing, and if U S equals a half, U plus V upon T, we'll get there. So the distance between, if Cody's travelled 24 and Sarah's travelled 7.2, the distance between them, then you subtract those. Is equal to 24 minus 7.2 equals 16.8 meters.